Today's lesson, section 7.3a, we're talking about double angle, half angle, and product sum formulas. For this video, we'll just start with the double angle and half angle formulas, and then the next part 2, we'll talk about the product sum formulas. Okay. Now, for these formulas, how we derive them, I'll show them in class. I'll derive at least a couple of them just so you can kind of get a feel, because if you derive one, then the rest of them are kind of in the similar process, doing the same thing. So for sine formula, for double angles, so that means it's like x plus x. That would be the same thing as saying 2 sine of x cosine of x. For cosine, now cosine of 2x actually has 3 iterations of it, where you could write cosine squared minus sine squared, or 1 minus 2 sine squared x, or 2 cosine squared x minus 1. That one's pretty versatile. You can use, like, especially if you're proving an identity and you want to use the double angle for cosine, you can insert one that makes more sense for your problem. And so sometimes maybe you want everything to be in terms of sine, or sometimes you want everything to be in terms of cosine, or maybe it doesn't matter. You could put in both, but that would be something to keep in mind moving forward with your proving identities. And once we get into the next section, section 7.4 and 7.5, that'll be a handy piece of information to remember. Tangent formula is 2 tangent of x over 1 minus tangent squared. For your half angle ones, here for sine and cosine look very similar to each other. Like I said, I'll show you how we derive these. In tangent formula, it has 2 iterations of it. It's kind of like the opposite, or the flipping of it. For your sine squared, cosine squared, and tangent squared, there's actually, you can use your double angle formulas for cosine in the same sense for a different way of writing them. It's called lowering powers. So you're kind of another way of getting rid of the square, basically, if you don't want the square there. And then obviously you could put in something in for cosine 2x, but that's just the simplest way of writing it. Okay, so make sure you copy those down, keep them all in the same place with all your other identities. That'd be a good idea moving forward. Okay, so kind of like the last section for the last example where we're using the identities, here you're given a ratio of an angle, and you want to find the tangent, cosine, and sine of the double angle identities, just to see and understand how you can use them. So here, now because you have cosine, you need to figure out what your sine and cosine are, both of them. You won't really need to know the tangent, because tangent for your double angle, if it happens for your double angle, but for your half angle, you don't actually use tangent for the formula. So it'll only be if you're doing tangent of 2x that you need to know it. But since we create the triangle, we'll have it no matter what. So since we're in the second quadrant, that's where I want to make my triangle. Here's theta. Okay, so then adjacent over hypotenuse, so it'll be -2 over 3. And then I need to figure out what the sine or the y value is. So -2 squared plus y squared equals 3 squared. So 4 plus y squared equals 9, minus 4 minus 4. That gives me 5. Since we are in the second quadrant, y is positive, so it'll be the positive square root of 5. Okay, so then from there, now if I want to find sine of 2x, okay, here you want to first insert in the formula that you're talking about. So 2 sine of x cosine of x. So if I throw in my x value there, so my sine for sine of x is going to be, I guess I should write that this is x, not theta, my bad. So sine is going to be the square root of 5 over 3. And then for cosine, it's going to be negative 2 over 3. Okay, so this is the same thing as 2 over 1. So now I can multiply across. I get negative 4 square root of 5 over 9. Okay, so that would be the value for sine of 2x. Cosine of x, like we said earlier, you have multiple choices, so it doesn't really matter what you do. Let's use the cosine squared minus sine squared 1. And now it doesn't matter which one you use because you're going to get the same thing for each one. We already know what cosine is, negative 2 over 3 squared minus, and then square root of 5 over 3 for sine, and that's squared. Okay, so I square both, so I get 4 over 9, and then over here I get 5 over 9, so that actually gives me negative 1/9. So that's my cosine of 2x. You don't have to do it for each one, just pick one and then do the identity. And then tangent 2x, so 2 tangent of x over 1 minus tangent squared x. So tangent is your negative, or sorry, square root of 5 over negative 2. Okay, so let's insert that in where we see a tangent. So 2 times square root of 5 over negative 2. Then 1 minus square root of 5 over negative 2 squared. Let's simplify. So here, I can actually cancel out the 2's. So that leaves me a negative square root of 5. This one will be 1 minus 5 over 4. So let's make the 1 over 4 fourths. So I get negative square root of 5 over negative 1 over 4. So that makes it positive. This is the numerator, so it's like over 1. So I can flip this up and say square root of 5 over 1 times 4 over 1. So that gives me 4 square root of 5. So that would be my tangent for this problem. Okay. Now let's try to kind of do the same thing if you're trying to find the half angle identities for all your stuff. So you're given a ratio for sine, and this is for angle U. So your sine, you're in the first quadrant, so everything's positive, so opposite over hypotenuse. Let's find your x. So 4 plus x squared equals 25. Subtract 4. And then take a square root since you're in the first quadrant. Okay, so you get x equals square root of 21. So now, let's do our half angle identities here. Now the plus or minus just deals with if or where your angle actually lands. So because U is in the first quadrant, that means that our angle is going to be positive, our ratio is going to be positive, and so is it going to be the same thing for cosine as well. So I put in 1 minus, it would be cosine of U over 2. So like I said, it's just plus, so I can drop the plus or minus if I would like. 1 minus in the cosine is going to be square root of 21 over 5 over 2. So here, with these, you got to make common denominators in the numerator, so 5 over 5, and then multiply it by the reciprocal. So I get 5 minus square root of 21 over 5. times 1 over 2, and that gives me 5 square root of 21 over 10. So there's my sine. Cosine of u is going to be very similar, just 1 plus cosine of u. Okay? Now, same thing, you're in the first quadrant, so it's a positive square root. So 1 plus, same thing, square root of 21 over 5 over 2. Make common denominators, just like we did in the last one. So you get 5. You can multiply by the reciprocal as well. So 5 plus square root of 21 over 5 times 1/2 gives you square root of 5 plus square root of 21 over 10. Okay? Now tangent, because you have two different ones to choose from, it doesn't matter which one you choose. So here, let's say we chose the 1 minus cosine u over sine u. Okay, so here we use both cosine and sine. So 1 minus the square root of 21 over 5 divided by, let's go back, sine was 2/5. Okay, so we'll make our common denominators here. So I get 5 minus square root of 21 over 5. I can multiply by the reciprocal, so the 5's actually cancel out. So you're left with 5 minus square root of 21 and over 2. Okay? And that would be my answer. Right? And that's part 1. Part 2 is next. Okay? Have fun.